All right, number 5, they gave us a function with a constant involved. And for each problem, they have kind of a different question about a different k. So let's start with 5a. So 5a says, find the value of k such that the slope of the line tangent to the graph of f at 0 equals 6. So another way of saying that is f prime of 0 equals 6. So I need an f prime formula. This is a 1 over function, so I'm going to do negative 1 over the function squared. And then I'm going to multiply, don't forget chain rule, by the derivative of what the parentheses is. So that's 2x minus 2. And if I simplify that, I get negative 2x minus 2 over x squared minus 2x minus k squared. Right? So that's f prime of x. F prime of 0 is going to be this expression with 0 plugged in. So I'm going to plug in 0 on the top, I'll get 2. And on the bottom, I'll get negative k squared, which is just k squared. And I want that to equal 6. So 2 equals 6k squared. K squared equals 1/3. And k is plus or minus square root of 1/3. It says in the problem that k is greater than 0, so I can rule out the negative. K equals the square root of 1/3 is my answer for part A. All right, part B says, let's take our function and plug in a specific number for k. So it's going to be x squared minus 2x minus 8. And then they ask us to perform an integral of that function. And after a little bit of inspection, I hope you recognize that that's a fraction with a denominator that's quadratic that can be factored. And so I'm going to view this as x minus 4 times x plus 2, and then rewrite that as a over x minus 4 and b over x plus 2. So this is a partial fractions problem. All right, thinking about this, I know that a times x plus 2 plus b times x minus 4 has to equal the numerator of the original expression, which was 1. Plugging in a negative 2 gives me no a's, negative 6 b's, and so b is negative 1/6. If x is 4, then I get 6a, no b's, equals 1, so a is positive 1/6. So I end up with the integral from 0 to 1 of 1/6 over x minus 4, minus, because the b is negative, 1/6 over x plus 2. The 1/6 I can pull out in front, and I really just have 1 over x minus 4 minus 1 over x plus 2. These are both natural logs. And since I'm subtracting the two logs, I can put them together. So I get 1/6 natural log of x minus 4 over x plus 2. And my last step is to plug in the bounds of my integral. So I'm going to plug in 1 to that. When I plug in 1, I get negative 3 over positive 3, which is negative 1, but it's the absolute value, so it's just log 1. And then I have 1/6 natural log. When I plug in 0, I get negative 4 over positive 2, which is negative 2. Absolute value of that is 2. Log 1 is 0, and so this ends up being my final answer. Negative 1/6 natural log 2 is our value of our integral. All right, finally for part C, they ask us to use yet another k value, and this time do an integral from 0 to 2 of 1 over x squared minus 2x plus 1. And if we think about this in factored form, it's actually a perfect square binomial, x minus 1 squared. Thinking about this a little bit, especially the graph, we should recognize that it's a rational function with a asymptote at 1. You don't have to know exactly what the graph looks like, but it's helpful to kind of know this. And I'm integrating from 0 to 2. So anytime you have an integration problem like through an asymptote, it's potentially problematic because we don't know, as this graph goes forever upward, if this area is going to be bounded, or it's unbounded, but it could be a finite area or an infinite area, and it just kind of depends on the situation. So I have to do a couple things. One is I have to split this up into two integrals, and instead of going from 0 to 1, since 1's an asymptote, I'm actually going to have to create a limit problem out of this. So I'm going to have to approach 1 from the left, b, sorry. So as b gets closer and closer and closer to 1, what does this go towards? And as a second problem, I have the limit as approached b from the right, and this time I'm going to go from b to 2 of 1 over 1 minus x squared. All right, let's do the antiderivative. This is the same thing as x minus 1 to the negative 2. So when I do the integral, it's x minus 1 to the negative first with a negative out in front. And I can also write that as a negative 1 over x minus 1. I'm going to evaluate that from 0 to b, and I'm going to take the limit as b goes to 1 from the left. I get a final answer of negative 1 over b minus 1 minus a negative 1, so it's a plus, over 1 over, and then when I plug in 0, I get another negative. So it's actually a negative, negative, negative. So it's a minus here after all. All right, and the limit as b goes to 1 from the left, as b gets closer and closer and closer to 1, this is going to get closer and closer and closer to 1. When I subtract 1 from that, I get a very, very, very small number close to 0 but negative. And then negative 1 over a very, very small negative number is going to be positive infinity, right? Minus 1. What's key here is that you get infinity as an answer. That means that the limit does not exist. And that means that the integral is divergent. So we could show the same thing for the other part, but if any part of the integral diverges, then the whole thing diverges. So your work here is to show basically that you have a limit that goes to infinity or does not exist, and that means that the integral diverges.